Hey guys, it's me. We are kind of continuing some stuff with our matrix conversation that we started yesterday. So we are still in 7.2, which is technically called matrix algebra. And with that, what we are doing today is just looking at what are some types of matrices. And so I'm gonna go through a couple different things, and then we'll get after it with our calculator. So there'll be some calculator conversation happening today. Types of matrices. One that we don't use hardly at all, but may come in handy as you get further into more math, is the transpose of a matrix. And what we're doing there is we take an original matrix and we form a new matrix where we switch the rows of columns, switch the rows and columns, or switch the rows with the columns. So a new matrix where the rows and columns were switched. Oops. So just a quick little piece of information. So if this is A, and I'm just going to keep it pretty simple. Let's say A is just a 2 by 3. So let's just say it's 1, 2, 3, 4, 5, 6. Very boring. A transpose becomes 1, 2, 3. The first row becomes the first column. 4, 5, 6. Again, we won't do much with that. Where we're going to spend our time is looking at the inverse of a matrix. But in order to talk about the inverse of a matrix, I just want to clarify a couple things with the identity matrix. The identity matrix is a square matrix, and it can be any size. So to show that, I'm just going to say n by n, which is a square matrix, right? The rows and the columns are the same. That's what makes it square. A square matrix with ones on the diagonal, on the main diagonal. So we could have I shouldn't say I shouldn't say A, because for the identity, we're going to give it the letter I. Let's say we had I and it was a 2 by 2. It would look something like this. There's my diagonal. Everywhere else is zeros. I of a 3 by 3. Here's my diagonal. Everywhere else is 0. Okay? Now, the identity, we have identities in math all the time. 1 is the multiplicative identity because anything times 1 is 1. 0 is the additive identity because anything plus 0 is 0, right? So that's just kind of where some of that's coming from. We also have inverses in math, and that's where we are headed next. And inverses relate to the identity. So we can have inverse matrices, or inverse of a square matrix. I should probably clarify. Only square matrices get to have an inverse. And the whole point of an inverse is that if I do, if I say that the inverse of A is B, then when I multiply the two of them, it equals the identity. If A has an inverse, it is non-singular. If it doesn't, then it is singular. So if it does not, then it's singular. Okay. I know we're zooming through a lot of this vocab-y stuff, but I want to dig into some calculator. We can do the determinant. We are going to let our calculator do the determinant, but I'm going to show you how you could do it by hand. Determinant is a value for a matrix. It also tells you if the matrix has an inverse or not. But here's kind of the formula. So det A equals, or let me back up. Matrices are written with brackets. If you see it written with like brackets that don't have like the top or the bottom, then all of a sudden that turns into the determinant. So when I'm writing it with just vertical like bars here, almost like it's the absolute value, that's what I'm doing with the determinant. So up here, the purple matrices up there, they have the little like head and foot for the bracket. This does not, and that's what tells me I'm doing determinant. Anyway, so now to do the determinant, if I want to do it by hand, I do AD, right? I multiply on this diagonal. And then I subtract B times C, which is the other diagonal. A key thing with determinants, an n by n matrix, in other words, square matrices, right? That means the rows and the columns are the same. An n by n matrix has an inverse if and only if, throwing it back to geometry, if the determinant of A is not equal to 0, okay? And we can find that inverse. I'm going to show you the formula quick, but then again, we are going to live in the world with our calculator. Here's how we can find the to find the inverse of a 2 by 2, we do 1 over the determinant. That's what that formula equals. That should be recognizable. This right here is equal to det A multiplied by dA. So we switched on that green diagonal from before, and then we make negative on that purple diagonal from before. And we multiply that as some sort of scalar. Now, for us for today, here's what's going to be helpful to us. So I'm going to pop open my calculator. So I got my calculator open. You hopefully learned some stuff yesterday on how to do your calculator. If you haven't, then you might need to send an email and set up some time to get some help with that. Because we're going to be doing a lot of living in our calculator. So the first thing we're going to do is we're going to find the determinant of a matrix. So I've got a matrix, and it's 5, -3, 3, -6. Now this calculator, I can just set up my rows and columns like so. If yours doesn't do that, then that's where definitely we want to make sure we make some time to connect and help you learn how to use your calculator. So here's my matrix. Great. There it is. Okay. Now I locked it in. I want to do the determinant of that. The formula tells me I can do 5 times negative 6 minus 3 times negative 3. And that'll tell me my determinant's negative 21. However, I can also go into here, into the matrix menu, where it says math. Remember, matrix menu is just this little blue button by the D, and I'm going to click det. And then I'm just going to retype my matrix. I can do, I can do some things to get it back, but I'm just going to retype it. It's not too big. Okay, there's my determinant, and it matches. Okay. Now, this determinant is not 0, right? And so this means this matrix, I can do the inverse. So I'm going to, now this is an option on this calculator where I can come back and, wait a minute, I thought I could reprint it. Maybe not. Okay, well that's okay. I'm going to re-enter my matrix. Alpha zoom, it's a 2 by 2. I'm just going to keep grinding on the same one. Because in order to do an inverse on the matrix, we are going to, there's my matrix. So the symbol for inverse, hopefully you noticed in your notes, was that little -1. And so I'm going to go into the matrix menu. Nope, I'm not going to go into the matrix menu, sorry. I'm going to go into the button actually where the matrix menu lives. That's where I see that x -1, and I'm just going to push that and have it attached to my matrix. Okay? So there it is. Now, is it a beautiful one? No, it's kind of ugly, but that's okay. A couple things I can do. If I push enter, it doesn't, remember we said it wasn't doing much, but if I push answer, it'll store my matrix as an answer. And if I want to, especially if I'm having to type it into Delta Math, I can push math triangle frac, and it'll print it for me with fractions rather than with the decimals. Also especially helpful because I can't always read all of it, especially if I do a 3 by 3. So speaking of a 3 by 3, let's just grind on that real quick. I didn't show you how to do that stuff by hand because that would be kind of intense. So let's look at a 3 by 3 matrix. So here's what it looks like. So I'm going to enter it in. Alpha zoom. I need a 3 by 3 matrix. There it is. And 5, 5, 0. -1, -1, -1. 0, 2, 0. Okay, there it is. Now I'm going to take the determinant of that. So I'm going to go in my matrix menu, and I'm going to do the determinant of that matrix. Now, before I couldn't do the answer thing because I had calculated the determinant and it was -21. But here I can. So my determinant was 10. Awesome. Okay. So if it asked for me for that, I could totally just use that to do it that way. However, the question was, what's the inverse? So here's my matrix. I push the -1, and it tells me my inverse. Really nice decimals. You can change them into fractions if you want. If you want to, remember that's in the math menu. So between the matrix menu and the math menu, we're going to be getting our money's worth. Okay. All good things happening here. The final one I wanted to show you about was the transpose. So I'm just going to make a matrix. So alpha zoom. Let's get crazy. Let's make it a 3 by 4. And let's just go 2, 3, 5, 7. Let's leave one row of zeros because I'm feeling lazy. And then 1. This will make it easy to see. 1, 1, 1. If I want to do transpose, I go in the matrix menu, and I go over to the math, and I can see the T, and that transposes it. You can see how it just kind of almost rotates at 90 degrees. The first row is now the first column. So some cool stuff happening with our calculator. As you learn more and more, your calculators just become a more and more better tool for you. So make sure you ask questions on all of it, but also on how to leverage that tool. So you got it. Go do good things.